All right, we're about to go on a pretty wild thought experiment. It all kicks off with a really simple question about what you see. But trust me, it ends up at the very last moment of the universe itself.
So here it is. This is our starting point. As you get closer and closer to the speed of light, does your field of vision get wider or does it get narrower? Seems straightforward, right? Well, the answer to this is the key that unlocks one of the most mind-bending trips you can take in physics. Let's see what happens.
So, first things first. To even get our heads around this, we need to talk about a really bizarre trick that physics plays on you when you start approaching that ultimate cosmic speed limit. You know, reality itself, it kind of starts to bend.
There's a name for it, of course, relativistic aberration. And it's totally counterintuitive, but the faster you go, the more the universe in front of you seems to get pulled in and squeezed into what you can see. The best way to think about it is like your vision is a camera lens that's shifting to an insane fisheye, just pulling everything from the sides right into the center. And here's what that actually looks like. On the left, that's just us, standing still, our normal everyday view. But on the right, moving at near light speed, that cone of vision just blows up. It gets way wider. You're seeing more of what's ahead of you, all at once. And believe it or not, this one simple fact is the key to this entire journey.
Okay, so we need to go unbelievably fast to make our vision expand like that. But what in the world could get us moving that fast? It's not going to be a rocket, that's for sure. Nope. For this, we have to turn to the most powerful engines in the entire cosmos: black holes.
The answer is a black hole. Its gravity is just immense. It's the most powerful accelerator there is. So, in our thought experiment, we're not even building a ship. We're just gonna fall. As anything gets pulled in, it goes faster and faster and faster, getting ridiculously close to the speed of light. So as you take the plunge towards that black hole, two incredible things happen at the same time. One, your field of view gets super wide because of your speed. And two, this is the crucial part, time dilation kicks in. So for every 1 second that passes for you, millions, maybe billions of years could be flying by for the rest of the universe.
And this is where our simple little question about vision just takes this unbelievable, incredible turn. When you put those two things together, a super wide-angle view and the universe on fast forward, what would you actually see during that fall? This is it. This is the mind-blowing result. With time for the outside universe just screaming forward and your vision expanded enough to take it all in, you could, theoretically, witness the entire future of the cosmos unfolding right in front of you.
You would see everything. In just those few moments of your fall, you'd watch eons pass. You'd see the last stars flicker out. You'd see galaxies fly apart into total darkness. You'd even watch the final black holes themselves evaporate into nothing, until the entire universe reaches its cold, final end state, a heat death where nothing ever happens again.
Wow. Okay, so you can see the entire future, which naturally makes you wonder about the next question, right? Could you use this black hole telescope to look backward in time?
And this is where we have to make a really important distinction. Could you see the past of some distant star? Oh yeah, absolutely. We do that every single time we look up at the night sky. But could you see your own past? Could you look back and see where you started your fall from? No, that's impossible. That information is traveling away from you, and you can never ever catch up to it.
All right, let's have some fun. Let's take this whole idea and just push it to its absolute most speculative limit. Let's imagine a completely hypothetical mission set during the very final moments of our universe.
So let's set the scene. The universe is cold, it's dark, it's almost completely empty. All that's left is one single, ultra-massive black hole. And you know, some theories actually suggest that an object like that could be the seed for a whole new Big Bang, a new universe.
So what if we could use that? What if we sent a probe on one final mission to fall into that very last black hole, and in doing so, become the ultimate historian of the cosmos?
This would be its job. As this probe falls, it uses the time dilation and that expanded view to record the complete history of our cosmos, from start to finish. Then, and here's the huge theoretical leap, it would somehow have to survive the singularity and pop out into the next universe, carrying a perfect record of our own.
And that kind of brings us to our final and maybe most profound thought. If you could actually build a machine that witnessed our entire cosmos, from the Big Bang all the way to the final darkness, what one single question would you program it to answer? What is the most important thing it could possibly learn for us?